Hi, everybody. Glad to be back talking about Flang. There we go. All right, now there's a lot of Flangs out there. There's some really old Flangs. There's the Google Summer Code Flang, and then there's the Flang that we were working on, which we now affectionately call Old Flang. And Old Flang was an NSSA project, also done with NVIDIA and PGI, and in 2017 we contributed the code to open source. We've been working on it ever since then with a growing cast of contributors from ARM, from AMD, and most recently Microsoft has signed the CCLA. With Old Flang, sometime this week or next week, we should have it relicensed with the new LLVM license or the new Apache 2 license with the LLVM exception, and we'll be getting rid of the contributor's license agreement, so anybody will be able to contribute without going through NVIDIA at all. At the same time, we're going to open up committers to more people, first from ARM, but also people from OpenBSD, FreeBSD, Mac maintainers, and some Windows maintainers. So that's a pretty good thing. We present performance numbers every time. Here's 3 sets of benchmarks. It's the geo mean of the benchmarks, and we compare against GCC. So in each one, it's the lighter blue. That's GCC. That's normalized at 100%. And the PGI commercial compiler with a Fortran optimizer is in the yellowish color. And that is using an LLVM backend. So PGI uses a LLVM backend as well. Then the 2 left bars are LLVM 8 and then LLVM 7. So we do a quarter by quarter, or every release by release, we get some new numbers. And you can see in an older benchmark suite called Polyhedron that GCC does for G-Fortran does pretty well, and so does Clang, especially got better this time. The middle chunk is a new benchmark set, mostly floating point and arrays, where there's a special optimization that PGI does that the other compilers don't. But you can see that LLVM does a great job, and it's gotten a little bit better with the 8.0 release. And then the far column there is OpenMP, and that uses OpenMP runtime system. This is all done on a dual-core Skylake, so I think there's 80 threads involved. And PGI, again, has a couple of tricky optimizations in their conditional loop vectorization. And again, LLVM does pretty well. We didn't see a speed up this time, but I'm not sure why. We don't really dig into that every time we go through. So there's an old Flang, there must be a new Flang. Yep, new Flang. We used to call it F18. We started about 1.5 years ago. I've talked about our motivation before. The basic idea was that old Flang really wasn't appropriate to move into an LLVM subproject. So we started again, C++ 17, modern sort of look at how you should design a compiler. We're a little ahead of the curve using C++ 17, but we have a mitigation plan for when we're in the monorepo, which will start to move in pretty quickly. The whole thing's been developed in open source under Flang compiler F18. Anybody who wants to be a contributor so they can review the code, participate in code reviews, get on the mailing list, it's available to do that. We don't have any CLAs, there's no restrictions other than wanting to participate. So come on and join us. There's a couple of cool things that we are doing. One of them is we're using MLIR, and we have a high-level intermediate language. It was sort of inspired by Cyllin and the Rust intermediate language that we wanted to do for FIR. And we started working on that before MLIR was announced. And we were going down the same path. MLIR came out, I think it was at Euro LLVM last year. We took a look at it, we did some deep dives, and now we've defined FIR as a dialect of MLIR. And we're working away on that. And Eric is working both to make MLIR better with that team, and also working on FIR, and also the lowering into LLVM IR. So we use a lot more of it than, say, TensorCore does. The other thing we're doing is we're working with Johannes with, let me see, I can hardly ever say it, so I'm going to read it. OpenMP IR Builder. Usually it doesn't have a space in it, and I get very confused. And that's a high-level way to describe how code generation should be done for OpenMP. As OpenMP gets more and more complicated, as they add target offload and different constructs, we wanted to have one place where we could experiment, implement, optimize for both Clang and for Flang. And that's being done. And then people from ARM are actually taking that into the MLIR or into the LLVM. We're not exactly sure where we're going to implement that or where we're going to do the optimizations. We have lots of places you can look. We have the source code is Right now, it's still under Flang compiler in GitHub, and we have a mailing list. Normal place, there's also a Flang commits that you can subscribe to. We have alternating technical calls every week. There's a technical call and an administrative call, and that's it.
Thank you very much.